In this video, we begin looking at Chapter 4, Section 1 in the Larson text. And what we want to do is, in this first set of problems, find the general solution. So this is something we need to talk about, the general solution of the differential equation. So let's first talk about what a differential equation is. A differential equation is an equation that involves a derivative, or that has a derivative in it. And so all four of the examples that you see here all are equations with derivatives in them. So they are differential equations. dy dt is equal to 3t squared. dr d theta is equal to pi. dy dx is equal to x to the 3/2, and dy dx is equal to 2x to the negative third. Each of those are examples. Now we might just say that those are all just derivatives. dy dt equals 3t squared. That's a derivative. But it's also a differential equation that we can solve. Second thing we want to talk about is what it means to solve a differential equation. Well, to solve a differential equation means to find the function whose derivative is implied in that equation. So if dy dt is equal to 3t squared, we want to know what y is. What is the function whose derivative is 3t squared? So to solve a differential equation means to find y, to find f of x, to find the underlying function. Then the third thing that we want to talk about is the difference between a general solution and a particular solution. With all derivatives, you have to remember an important point. For example, the derivative of x squared is 2x. The derivative of x squared plus 5 is still 2x. The derivative of x squared plus any constant would still be 2x. So when we take the derivative, we lose any constants that are added or subtracted. When we solve a differential equation, we're not going to know. We'll be able to get back to the original function, but we won't know the constant. And remember, the constant just changes the function by shifting it up or down. It's a vertical translation. So we'll know the function family, but we won't know the specific function. And that's what we mean by finding the general solution. So we know that the antiderivative of 2x is x squared. But we don't know whether the original function was x squared or x squared plus 5 or x squared plus some other constant. So when we finish up, and I'll just use the integration notation to mean find the antiderivative of 2x. We know that that is x squared plus some constant c. And we would say that that is the general solution to the differential equation dy dx equals 2x. Alright, so let's take a look at what we have in these four examples here. We want to find the general solution of the given differential equation, and then it says to check the results by differentiation. So let's see what we have. The first equation, dy dt is equal to 3t squared. Now we can write integration notation. We solve differential equations by the process of integration. So writing integral of 3t squared dt is how we would find the solution, the general solution to the differential equation dy dt is equal to 3t squared. And we solve by increasing and dividing. So we're going to go to 3t to the third power divided by the new exponent 3. We see that the 3's cancel, and we end up with, of course we would say that's plus c. We end up with t cubed plus c. That is the general solution to the differential equation dy dt is equal to 3t squared. Alright, let's go on to the next. Number 6, dr d theta is equal to pi. Remember that pi is just a constant, and our variable would be theta, so we can treat that as pi times theta to the 0 power dt. We're going to increase the exponent of theta to 1, divide by 1, and so that gives us pi theta over 1 plus c, which is simply pi theta plus c. So we have the general solution, again, to that differential equation. Number 7, dy dx is equal to x to the 3/2 power. Once again, we solve the differential equation through the process of integration. So we set up the integral. The integral of x to the 3/2 dx is equal to, now here we're going to increase the exponent by 1. So we're going to increase from 3/2 to 5/2. Then we're going to divide by 5/2 plus c. But dividing by 5/2 is the same as multiplying by 2/5. So in the future, I'm just going to go directly to multiplying by the reciprocal of the new exponent. And so we get 2/5 x to the 5/2 plus c. That's the general solution, again, to the differential equation. dy dx is equal to x to the negative 3/2. And the final one, dy dx is equal to 2x to the negative 3rd. We're going to solve that through the process of integration. So the integral of 2x to the negative 3rd dx is equal to, we're going to increase the exponent from negative 3, increase by 1 gives me 2x to the negative 2nd, divide by the new exponent, which is negative 2 plus c, and the 2's cancel. We end up with negative x to the negative 2nd plus c, which you could also write as negative 1 over x squared plus c. And so again, we've talked about differential equations, solving differential equations, and what is the general solution to a differential equation. We'll talk about particular solutions in another set of problems. So that'll do it for this.